This is the second part of a presentation about IT in a modern enterprise. The presentation was originally held at the Nordic GSE Mainframe Conference in Oslo, May 2012.
I have mentioned UEMA a couple of times. I consider it one of the most important and interesting new developments in IT in the latest few years. UEMA means Unstructured Information Management Architecture. UEMA was developed by IBM Research and is the core of technologies like Watson, which can win Jeopardy and help doctors. Provided that the doctors dare challenge the diagnosis from a computer and continue to listen to their own experience and intuition. UEMA is also used in products like IBM OmniFind and LanguageWare. UEMA is freely available as open source from Apache and has been extended by universities, companies and nerds to many areas of special knowledge. UEMA can run as an Eclipse plugin, which means it can also be embedded in the Rational Developer tools. UEMA was developed by a team of IBM researchers, led by Dr. David Ferrucci. It is an architecture where you can add components. A collection reader gets the input from text, chat, websites, HTML, audio or video and loads it into a CAS, which is a common analysis structure and storage. Annotators tag the input based on the data model you have defined. Consumers store the annotated documents in databases or wherever you want to. All these components are Java programs. The developer toolkit is based on Eclipse and can be plugged into your Rational Developer workbench. Dave Ferrucci describes himself as a survivor of the nuclear winter of artificial intelligence. He thinks that artificial intelligence and similar technologies of the 1990s were trying to achieve a perfection that is not possible. The philosophy behind UEMA is the opposite. We make models that we know cannot be perfect. But we might make several models and compare their results to each other. If they match, we might be right. In this view there is not a correct answer, but a number of possible and probable answers. This is in contrast to the web search engines that look for one right answer. And it is much more like the way humans think. My own personal research project was to create a tool to assist my genealogy hobby. One important source is probates, which are handwritten in old language and old documents. A probate is a process by the property of a deceased person is transferred to the heirs. A lot of genealogical information can be found in probates, and volunteers have typed out extracts in different formats and placed them on the internet. These extracts could be converted from unstructured to structured data and made searchable, for example in a relational database. This is a good case for UEMA. The first thing we need is a data model to guide the annotation of the source documents. Genealogical data has been standardized in a model called GEDCOM, which is Genealogical Data Communication, and this is shown here using Rational Software Architect. For my purpose a simplified data model is sufficient. It is shown here. It is used for the annotation tags and for the tables in the database. This is a Danish probate extract as done by Mrs. Aurelia Clemens of Idaho in the US. This is a Danish probate extract as done by Erik Bregel in Denmark. It is obvious that we need a separate annotation algorithm to interpret this format. This is a Danish probate extract as done by Erik Reinhard Nielsen in Denmark, which is even more different. So the challenge now is not to read old documents, but to annotate the different transcriptions into a structured format that can be stored in a relational database. I use the default collection reader, which opens all files in a directory and reads them all into memory. Then I wrote annotators for each probate extract format and for each data type, such as names, dates, places and sources. In each case I chose to accept that the patterns I defined were not exactly correct in all cases, but almost always found all entries. The consumer program then stored the resulting probate records in a relational database. One example of separate formats is dates. Here are a couple of examples. It is normal in UEMA to use regular expressions to identify and transform patterns. Regular expressions is a pattern recognition language with implementations in many programming languages. If you are using Kix, it could interest you to know that regular expressions are supported both by Java and by PHP. Here are a few examples of regular expressions used to map dates in different probate extracts. The UEMA components are Java programs, which all have XML definition files to identify them to the underlying UEMA runtime. UEMA provides wizards and tooling in the same way as Rational Developer and other Eclipse products. This one is an example of a date annotator in the XML wizard and as Java code. Normally you would run the entire flow of readers, annotators, and consumers in batch. If you have more than one annotator, they can run in parallel. In this example, an annotation engine has been started from within Eclipse and asks for parameters. When it has run, you can watch the annotations in a viewer. This is a document where dates have been annotated, as seen in the viewer. This is the actual annotated document. The entire text is embedded in an XML entity, and so is each tag. Each tag has a type, an identification and start and ending offsets in the document. Now we have seen the technical side, let's look at the logical design. A probate is a subset of the extract document. It must be identified uniquely, and the relevant tags connected to it, so we can turn them into search keys in the database. This is my model of the parts to be tagged, and some of the algorithms for one of the formats. It is not perfect, but it is good enough for my purpose. And this is the algorithm to combine the entities into a single probate. Still not perfect. A few probates will not be identified, and some names and places will be misunderstood. So here is a document, which has been annotated with several different tags, as seen in the viewer. When the document has been annotated by all the annotators, the consumer program stores my data in the database. I have been using DB2 and Derby on different machines. I could also have a consumer program make an index, store it in IMS or tag it for a semantic search engine, if I had one of those. So, here is the full implementation. It can be used for very many different things. From my little hobby through sentiment analysis to fraud detection and military intelligence. Many of the open source annotators are supplied by universities and handle healthcare and medical research. In my own example, all that was missing now was a small program to embed the SQL search in the resulting database. Some entry fields in the list view. And then a text pop-up to make the result readable. Now I had a new tool for my hobby. As soon as I started using it, I found that a quite big part of my research were built upon a wrong understanding of one of the probates, and had to start this part again from scratch. Let us call that a proof of concept. This was a short view into what I consider the future. Where does this leave the mainframe programmer? I don't have any ready answers for the questions, but we owe it to our companies and to ourselves to search for new areas. We have the new tools like Rational Developer. We must use them to make it easier to cross over both ways. Now all we are missing is the risks that they pose on the enterprise and on personal privacy. You can find all sorts of insight using the new technologies. Quentin Hardy reported in the New York Times March 28, 2012 about what he called bizarre insights from big data. A company called Kaggle had done this kind of analysis and found some unexpected patterns. But this is not a small and esoteric niche. The Obama administration has recently announced a big data research and development initiative with $200 million in investments. It is aimed at using big data for scientific discovery, environmental and biomedical research, education, and national security. But an enterprise has to tread carefully. I mean, do you want to enter a contest to win a trip to Rome? All you have to do is like Airwick on Facebook. You may not even know Airwick is, but as the price of entering that contest, You've just given Facebook permission to make you a spokesperson promoting the brand. And that has raised the ire of Facebook users, who has brought a class action lawsuit in Vancouver against Facebook. Facebook has vowed to fight back. Also, Google is running into problems with all the data that can be related to actual people. So you might face a situation where the enterprise has used all the new possibilities to know everything about its customers, but they hate it for that very same reason. You should probably be careful not to store personal data, but to use the information anonymously, in mass scale and for statistics. Not only can they get upset, you could even break a few laws. Maybe you used to think that you could hide on the internet, because it was so big and unstructured. This is obviously not so anymore. January 25, 2012, the European Commission proposed a comprehensive reform of the EU's 1995 data protection rules to strengthen online privacy rights and boost Europe's digital economy. These are some key changes in the reform. They aim at both being less bureaucratic for enterprises and more private for citizens. So we have talked about what a modern enterprise is, about a new data model, about the modern developer, and about infrastructure in a modern enterprise. I have given a practical example, and we have discussed the risks. There are a few good UEMA sources, if you want to try it on your own. Thank you for your interest.
You are welcome to contact us at Exact Consulting for further discussions, both on these subjects and on enterprise modernization in general.